these are the topics from where the questions will be taken. You can try to write them down, although I'm going to record it for the sake of those who are not here. The chapters, the finals will have 10 to 12 questions. And each question will have at least two parts, A, B, sometimes C. And in most of the questions, one part would be a conceptual question, which would be a law or a definition. And I'm also going to give a list of the main laws and the definitions that you need to know. But first, let's take a look at the chapters, the topics. All questions will be asked only from what I'm telling you, because it's not easy for you to study everything. Okay, number one, one of the questions will be from oscillations and waves. So in this question, one part will be from oscillations, and the other part will be from waves. Two parts. And oscillations, you just study about what the spring constant is, F is equal to kx. Study the formula for time period of oscillations of a spring, which is T is equal to 2 pi square root m by k. Just refer that. And also the time period of oscillations of a simple pendulum. Time period of oscillations of a simple pendulum, which is T is 2 pi square root L by G. For a spring, it is 2 pi square root m by k. And then look at the equations for simple harmonic motion, like x is equal to a sine cos omega, or sine or cos omega t plus phi. Know what these terms stand for. A is amplitude, omega is angular frequency. So I talked a little bit about that because we did that in 24-25, but it's connected to waves. You see, that's why I want to have a question. The second one will be from sound, and I want you to just focus on two topics in sound. One would be intensity of sound measured in decibels. The other is Doppler effect. So it could only be either from intensity or Doppler effect. The third one, motion of a particle in an electric or magnetic field. Particles in electric and magnetic field. I'll go over the formulas during the review session, so I'll just list the topics. 4, capacitance, capacitors, and mainly combination of capacitors. Combinations, different combinations in series and in parallel, and you know. 5, combination of resistances. Then another question would be either from RC circuits and Kirchhoff's laws. Either you have RC circuits and Kirchhoff's laws. The next question will be from torque on a current carrying loop in a magnetic field. That is, if the loop is suspended in a magnetic field and if it's carrying a current, what is the torque acting on it? Applications of Amperes Law. This will be a derivation where you have to find the magnetic field due to a straight conductor, due to a loop, you remember that? Due to a loop and a solenoid, or a toroid. There are 4. Applications of Amperes Law. Field due to a straight conductor, field due to a coil, a solenoid, or a toroid. Next, that's one of my favorites, Lcr circuit, where you have to calculate the impedance, the current, the voltages, the phase angle, the power, LCR or LRC circuits. You have to be able to draw images formed by mirrors and lenses, and also know the calculations. Of course, the formulas, the equations are the same for both. But remember that a convex lens produces both real and virtual, right? But a convex mirror produces only virtual. It's opposite, so remember that and just learn to use those three formulas. One is for distances, 1 by DO plus 1 by DI is 1 by F. Magnification is two formulas, just those two. Then wave nature, which we just finished. And in this big chapter, mainly focus on interference due to two slits, double slit, and when it comes to diffraction, grating. So you need not go about diffraction due to a single slit and polarization and all that. You need not. Just look at interference through a double slit, diffraction through a grating. So I'm just giving you the two topics. And the last is relativity. Okay, the entire chapter. Those are the topics. So there may be 10 to 12 questions, and like I said before, each question has at least two parts. Now, to tackle the second part, you have to know some definitions and laws. I'm going to list a few, but don't think that it'll be confined to that. You can make out the important definitions and laws. If there is a technical term in physics, I will ask you that. I could ask you that. Any technical term, you have to know. Need not be the exact sentences or anything in the textbook, but you have to know what it is. But when it comes to laws, you have to be a little bit more careful. Okay. I will try to ask questions just from this, but that is not 100% possible. Definitions and laws, mainly. Starting with oscillations, what is the spring constant? What is a progressive wave or a stationary wave? What is Doppler effect? You should be able to explain it. And again, I'll go over all this during the review on Sunday. Just telling you what it is one time.
Is it Sunday or Saturday?
It's a Sunday. Maybe we change. We'll talk about that. Beats, resonance, all those are from waves, you see that. And then you go to the next one, Coulomb's law, Gauss law, definition of an electric field, definition of electric potential, what is a capacitance, what is Ohm's law, electric power. Remember, there are three equations for electric power. You have to be able to define that. And then the most popular, Kirchhoff's laws. Conversion of a galvanometer into an ammeter or into a voltmeter. You may want to go back and when we wrote something about electric circuits, you could also be asked a problem on Kirchhoff's laws. So go back and write it in the chapters, the 12 questions. I think I did not mention Kirchhoff's laws, did I? So included with combination of resistances.
You put it with RC circuit.
Did I talk about Kirchhoff's laws? Okay, fine. Lorentz force, that is actually the combination force that acts on a particle in an electric and a magnetic field. Lorentz force, Amperes law, Biot and Savart's law, Faraday's law of electromagnetic induction, what is an inductance? Then laws of reflection and the laws of refraction. Total internal reflection, TIR, stands for total internal reflection and the conditions. Rayleigh's criterion for resolution of images by a telescope. What is polarization? And almost towards the end, postulates of the theory of relativity. What is time dilation? Length contraction? And then relativistic momentum, although I have not written it. So these will be the topics from where I'll pick questions on the final exam. And I have just recorded all this and put it on YouTube today, so you can see it. Everybody can see it. All right. Thank you.